Welcome back to inverse functions. In our first video, we looked at how the rules act on the outputs of the function and produce corresponding inputs. So the inverse reverses what the function has done. We reviewed that there are three different types of mapping. We have mapping where every domain value is mapped to one range value. We also looked at where you can have two domain values mapping to one range value. And that also is a function. And then we showed an example of something that is not a function. Now, part B here is what I want you to pay particular attention to. Clearly, not all functions have inverses. If they all did, we probably wouldn't be having this conversation or making this video. But we need to think about what criteria do you think a function must have to be an inverse or to have an inverse? Pause the video and see if you can think up an answer here. The reality is that in example 1 or exercise 1 part B, you had this shape where you had a parabola and there could be two outputs at the same height given different inputs. The definition that provides a function an inverse is here. Function f is called a one-to-one function if no two inputs map to the same output. So this example here that we already talked about is not invertible. I don't know if I just made that up or that word up or not, but so the very formal definition of this idea is saying that if you put an input x sub 1 into your function and a different input x sub 2 into your function, they cannot give you the same output. If that's the case, it is not a one-to-one function. So this example that I'm showing you here in the first part of the video is not a one-to-one function. Given the graph of a function, we'll use horizontal line tests to decide if it's one-to-one. Just as I did up here with our example, we can see that a horizontal line test hits two different points on the function, and therefore it's not a one-to-one function. So let's go ahead and graph some functions and decide which functions are one-to-one. I know that h of x is a cube, which means it's going to have this general shape. And by now, you should know that transformations say I'm shifting it down 3 units. So my function will be a cubic shifted down 3. If I check to see if this passes the horizontal line test, it absolutely does. In this example, there are no two domain values that map to the same range value. Therefore, this is a one-to-one function. If we look at x plus 5 raised to the second power, we know that this is a parabola shifted to the left 5 units. That's the general shape. If I check it with the horizontal line test, I can see that there are several different points where we touch the curve in more than one place. Therefore, this function, even though it is a function, it is not a one-to-one function.